The difference between solving an algebraic equation and a trigonometric equation is that trigonometric equation can have several solutions. Infinite solutions are possible in trigonometry. Say for example, sine x is 0 and we want to find x. You know how sine x is defined as a function. If this is a unit circle, then sine is defined as the y coordinate. Y coordinate is 0 here also, it is 0 here also. And you can take several rounds and come back to this position, right? So, aren't there infinite solutions? X can be 0, x can be pi, x can be 2 pi, 3 pi, minus 3 pi, 100 pi, 1000 pi. They are all valid solutions. Our purpose is to write all of them and represent them in such a way that if you just change one number, then all of them are included if you just change one number. So suppose I write x equal to n pi, and there n is an integer. I just have to change n, and all those solutions, 0, pi, minus 4 pi, 1000 pi, all of them are included in that. This is called the general solution. X equal to n pi is called the general solution. Now suppose another equation is cos x equal to 0. Cos is defined as the x coordinate when we have a unit circle. X coordinate is 0 here also, here also. So clearly, odd multiple of pi by 2. Where n is any integer. Well, 10x is 0 when sin x is 0. So this is same as what we have discussed earlier. Where n is an integer. Likewise, now can you say something for this?
So
What will be the general solution?
So odd multiple of pi by 2.
Odd multiple of pi by 2. Cot is 0 when cos is 0. So odd multiple of pi by 2. Any idea about this? What will be the general solution, if any? I have given a hint. If any.
Sir, it is not possible to have a solution.
Not possible. Because sec is always more than 1 or less than minus 1. And likewise, cosec x equal to 0 has no solution. The reason is the same. Any questions? Let me know. We have finished all 6. Our earlier discussion was based on 6, but all 0 cases, all 0. Let's make it very general now. Not just 0, but anything. So sine x equal to anything. What is the general solution to this? When I say anything, anything possible, of course, between minus 1 and 1, that is. Now, I can find one value of x, isn't it? Say, for example, sine x is half. X can have so many values, that's why we are discussing general solution. But any one value I can find out, I can say, for example, that x is 30 as one solution. So that any one solution of your liking, you can find out. And that will be a particular thing. Say that particular thing is called alpha. It could be 30 degree here. Nobody would like to choose a complicated value of alpha. It is entirely your choice which alpha you choose. So you of course would not like to choose 390 if 30 is an easier choice. So normally alpha is chosen as small number. That's not a rule, that's a convenient practice. So then I can write sine x equal to sine alpha. Right? Actually, it was easier to handle things in terms of alpha than in terms of k. So we chose this approach. using this formula. Two things are possible. Either this is 0 or this is 0. If cos is 0, we know that this thing is odd multiple of pi by 2. If sine is 0, we know that this thing is some integer into pi. I'm just rewriting it. 2n plus 1 is an odd number, right? I have got minus 1 into alpha, minus 1 into odd, minus 1 to the power odd. Should be no problem. And here it is 1 into alpha, but 1 can also be written as minus 1 to the power e1. 2m is e1, right? 2m is e1. Up to this point, any questions? Let me know. Now, think like this. It is either or type of case, right? Left or right. Right side says that x can be some even number into pi plus minus 1 to the power the same even number into alpha. And left side says that it can be some odd number into pi plus minus 1 to the power the same odd number into alpha. It is either of the two is fine type of case. It's not that it can be only this or only that. You're happy with even that left side also, you are happy with the right side also. So that means you are happy with either even or odd. Where n is any integer. You get the point. That should be the general solution. where n is any integer. If you have any questions, then let me know. Now, cos theta equal to k. So first we choose some specific solution. So let's say x. Let's call that specific solution or particular solution to be alpha. Right? So this is what we have, and that means now right side says that E1 into pi plus alpha is fine, and other one says that minus sign is also fine. So one says plus sign is fine, other says minus sign is fine. And it is or type of situation. Any of them will go type of situation. Any of them are acceptable type of situation. So the general solution would be even into pi plus or minus alpha. So for even number you can use anything. You can use 2p, 2q, 2n, whatever you like. Let's use 2n for even number, where n is any integer. That's it. Any questions? Let me know. Next, 10x equal to k. Choose any one value of x that satisfies this equation. Call that value alpha. Right? Convert 10 to sine and cos. Now that's a general good thing about this type of pattern. Whenever you have 10a plus 10b, 10a plus 10b has no formula, right? Whenever you have 10a plus 10b or you have 10a minus 10b, none of them have got direct formula. Converting them to sine and cos helps. You can see that right here. Why does it work? You can see after taking LCM, why does it work?
So n pi plus alpha.
Look at the numerator. So whenever you have 10a plus 10b or 10a minus 10b, something like that works well in the numerator. If you like, convert them to sec. Now you know that sec never lies between -1 and 1. So both of those sec are not going to be 0. That will leave you with only one choice, that is sine of x minus alpha equal to 0. And what does it mean if sine of x minus alpha is 0? X minus alpha is?
It's a 0.
0 is some particular solution. What is the general solution?
So n pi.
N pi. N pi. So it means that x minus alpha is n pi. which means that x is n pi plus alpha. That's it. Now what about other three trigonometric functions? Suppose you have got cosec x equal to k, which you can always write in terms of alpha. Cosec x equal to cosec alpha. Then by taking invertendo you will get the same thing. And for that, this will be true. So sine or cosec, same story. Likewise, suppose you have got sec x equal to sec alpha. I mean k, which you can write as sec alpha, where alpha is just one value of x satisfying the equation. Then by taking invertendo you will get this. And you know what is the solution to this, general solution? Right? And likewise for cot, if we have got cot of x equal to k, then taking invertendo, we have this. Done. Out of the three forms that we have discussed, this appears to be the simplest of all. All others have got some plus minus type of behavior. Sine has got minus 1 to the power n. So depending on n is even or odd, plus minus signs would come. So sine has got plus minus behavior built into it. Cos solution itself has got plus minus. So 10, general solution for 10, that seems to be the easiest of the three. Now you know that it is possible to convert from one trigonometric function to another by some adjustment. So if you are solving a problem, then it is possible to solve that problem in sine form or in cos form. We have discussed three forms: sine form, cos form, and tan form. These are standard results. When you are solving a problem, you can solve it in sine form also, cos form also, because sine can be converted to cos and vice versa. And these two forms look different. Sine form has got minus 1 to the power n. Cos form has got plus minus. They look different from each other. But it may happen that for some problem, In fact, it will happen that if you are solving one problem, you're trying to find out a general solution. General solution at its face may look different. Some student doing it in sine form gets some -1 to the power n type of behavior. Some student doing the same problem in cos form may get another type of looking result. But how can the solutions be different? Assuming both have done it right, they can't be wrong. The final answers cannot be wrong. But one has done it in sine form, other fellow has done it in cos form. So one fellow gets -1 to the power n form, other fellow does not get -1 to the power n form. So it may happen that when you are doing these problems, your answers are not matching with the answers given in some textbook. It may happen because the author of that question, say, has solved it in cos form and you have solved it in sine form. So your answers don't seem to match. Or if you're doing an objective question, it has got 4 options. All 4 options have got -1 to the power n, and you have solved the problem in cos form, which does not have -1 to the power n. In objective question, you can always first see the options. If you find that all options have got -1 to the power n behavior, then you better do it in sine form. So what I'm trying to tell you is that in this topic, even if everything is right, the general solutions may look different at their faces. Just the face is looking different. But from the inside, they are both same. From the inside, they are both same. If they are right, they have to be the same. So one way to test this is to find the specific solutions. General solution is in n. But when you find out specific solutions, put n equal to 0, put n equal to 1, put n equal to 2, -1, -2. Find 3, 4 solutions specific from one case. Find 3, 4 solutions specific from the other case, and then tally them. There it cannot be different. Yes, that may happen that by putting n equal to 0 in one solution that you get, that may come by putting n equal to 1 in another solution. N is some integers. So in one solution, you can get some answer by putting n equal to 0, and in other solution, that same answer may come by putting n equal to 1 or -1 or 2, whatever. All that is fine. N is just an integer. If you would have noticed while doing some general discussions, I took n and m. Look at that. I took n and m. And there was a reason for doing like that. I'm just trying to say that in left side, if you are putting n equal to 1, then it does not mean that on the right side also you have to put n equal to 1. Right side is some integer m. If left side you put 1, right side you can put 10. What's the problem? So I just chose m to highlight that they don't have to be the same necessarily. Both left and right sides, integer choices, they don't have to be the same necessarily. All right. So what is the general solution of this?
N pi by 3.
What is that?
So n pi by 3.
N pi by 3. How can it be like that? Alpha is pi by 3. Yes, go ahead.
Sir, is the answer n pi plus minus 1 raised to the power n pi by 3?
Correct. That's correct. Any questions? Let me know. Now normally we would choose the small value for alpha, but tell me technically is there anything wrong with this? If somebody chooses alpha equal to 2 pi by 3, technically speaking, is there anything wrong?
No, sir.
Nothing is wrong. Nothing is wrong. So while it's not a common practice to choose big angle for alpha, technically it's not wrong. How about this one? Now this one has plus minus sign. Basically alpha can take two values here in this case. So while tan solution doesn't have plus minus, because alpha has got two possible values, we can combine these two and give one final answer. Top one is also okay, bottom one is also okay. Any questions? Let me know. Now, this one we can do either in sine form or in cos form, our choice. Suppose we want to do it in cos form. Then I will convert sine to cos. Right? Whichever you like to call that alpha. I'm choosing the small one. Small to look at, that is. So 2n pi plus minus alpha. I'm looking for x. So bringing this bx to the left side. That's it. Minus will also work, plus will also work, and n can be any integer. Any questions? Let me know. Somebody could do this problem in sine completely, and the final answer could have looked different. It could have minus 1 to the power n. So if there are no questions, can we stop now?